All right, let's take a look at the Unit 4 review. All right, answer the following questions for the solid parabola and label on the graph. So what is the vertex? So the vertex here is the lowest point. So that's our vertex, and our point is at -5 and -2. What is the equation for the axis of symmetry? So the axis of symmetry is the vertical line that cuts the parabola in half. So if you think back to when we talked about horizontal and vertical lines, this would be a vux. It's a vertical line, and whenever we have a vertical line, it's always going to be x equals. So this is touching the x-axis at -5. So our axis of symmetry is x equals -5. And we want to focus on this equation. So it's not just a number, it's actually an equation, x equals -5. So since this parabola is opening up, it has a minimum value. So the vertex here is also the minimum value. So when we find the minimum value, we're talking about the y value of the vertex. And so the minimum value is -2. The roots of the parabola are where it touches the x-axis. So it's these two. So here it's x equals, we have -3 and -7. And then what's the y-intercept? And just looking at the graph, it doesn't touch the y, so I can't answer that question, so I'm just going to put a question mark. Alright, we're going to answer the same questions now for the dash graph. What's the vertex? So the vertex is the highest point of this graph, and that's at 2, 5. What is the equation of the axis of symmetry? So the axis of symmetry is that vertical line that goes through the vertex. So since our x value is 2, our equation is x equals 2. Does the parabola have a maximum or minimum? So as we travel along our graph, our y value here is -7, -5, 0, 3, and then it peaks here at 5 and then starts going back down. So our maximum value is the y value of the vertex. And so that's going to be +5. So it's a maximum of 5. And then I don't want to scroll down and miss the graph, so I'm just going to answer the rest of the questions. So what are the roots? So it touches the x-axis here and here. So that means my roots for the dash one are x equals -1 and 5. And then what's the y-intercept for the dash graph? That's here at 3, and so the y-intercept is 0, 3. Alright, standard form of a quadratic, we have y equals x squared minus 6x plus 1. And the question is, does it open up or down? And this one, since the a value is positive, that means it opens up. And then I'm going to go to number 3 and find the vertex first. So to find the vertex, we use the formula -b over 2a. And so here, our a value number in front of the x squared, so it's 1. Our b value is -6, and our c value is 1. So it's -6 over 2 times 1. So 6 over 2, which gives us 3. So when I'm finding the vertex, this negative b over 2a gives me the x value. Now to find the, if that's my input, to find my output, I just take that 3 and I plug it in. So I'm going to use the space down here. So it's going to be 3 squared minus 6 times 3 plus 1. So 9 minus 18 plus 1. So that's -9 plus 1 is -8. So my vertex is at 3, -8. And like we talked about in the last problem, the axis of symmetry is the vertical line that goes through the vertex. And so that's how I know that this is x equals a +3. The y-intercept is the c value. So that means that my y-intercept is at the point 0, 1. Alright, for when we have it in vertex form, so now this is a negative, so that means our graph is going down. Again, I'm going to go to the vertex. So since this is in vertex form, x is a liar. So here, we get the x coordinate. If x is a liar, that's -3. That -3 is what makes the inside 0. The number on the outside is my y value of the vertex. So my vertex is at -3, 5. So now the axis of symmetry is the vertical line that goes through. So that'd be x equals -3. Now, the y-intercept is going to require a little bit of work because this is in vertex form. So this tells us the vertex. It's not in standard form. It doesn't tell us the y-intercept. So we actually need to simplify this. So take the -2 times x plus 3 squared plus 5. And you need to expand it. So we're going to take that x plus 3 and actually FOIL it, or distribute, or simplify. So this becomes x squared. So x times x. And then x times 3 is 3x. 3 times x is 3x. So that gives us 6x. And 3 times 3 gives us 9. So now you got to distribute the -2. So we get -2x squared minus 12x minus 18 plus 5. And combine our like terms. So -2x squared minus 12x minus 13. So now this is in standard form. So now I know that this is my y-intercept. So my y-intercept is at 0, -13. Alright, so we're going to write the quadratic function for both graphs. And we're going to use the zeros here. So this one has a 0 of -7. This one here is x equals 1. So we start with the zeros. Then we write our binomials. So remember, x is a liar, so this is why this is going to be +7 and -1. Remember, the zeros are what we plug in that make the inside equal to 0. So now once we have our binomials, now we just FOIL it or multiply it. And if you needed to, you could do the box method by writing the x plus 7 here, x minus 1 here. And that would give us x squared plus 6x minus 7. So you can call it f of x or y equals. Alright, now let's do the solid one. So here we have a x equals 2. Here we have x equals 8. And we follow the same process. Write your binomials. And so x is a liar, so this is minus 2, minus 8. So this 8 is what makes this inside 0. The 2 is what makes this 0. And now you FOIL it out. And so we get x squared. That's going to give us minus 8x, minus 2x, for minus 10x. And then negative 2 times negative 6 is positive 16. So if I don't have a graph, remember the word roots is the same thing as zeros. So it's the same process. So we have x equals 5, x equals negative 6. Start with the binomial. X is a liar. And then FOIL it out. So as we're walking through these problems, if you haven't done them yet, you should try it before you watch the video. If you watch the video, then try it on a separate sheet of paper, then so you're not looking at the work as you're doing it. You need to be able to do it without looking. So that'll give us 6x minus 5x Alright, now with this one, everything's the same. X equals 0. X equals negative 7. So we've talked about this. The zeros is the same thing as the roots. So the process is still the same. So now here, this is where students kind of get confused a little bit. If you want, you could say x plus 0. If you want to say x minus 0, it doesn't matter for 0. And this would be x plus 8, or plus 7. And so you could keep the 0 here and multiply it out, but that's just an extra step, because x plus 0 is just x. So now when you multiply this, your function, f of x, is just going to be x squared plus 7x. And the last one, for our x-intercepts, remember x-intercepts, zeros, and roots are all talking about the same thing. Same steps. Start with our x, so x is 4 and x equals negative 3. Write your binomials. X is a liar. And FOIL it out. Give us 3x, negative 4, x, so minus x, and then negative 4 times 3, minus 12. So when we have a equation and there's no middle term, there's no bx term, if we move the c over, like in this problem, if we add the 125 to both sides, this is going to allow us to solve it using square roots. And so we get 5x squared equals 125. Divide both sides by 5. And so I get x squared equals 25. So now I square root both sides. I'm going to end up with x equals plus or minus 5. So remember, whenever we're solving, whenever we have that equal sign, we can take our answer and plug it back in just to check it. If I want to do a check, plug the 5 in where the x is, and see if it equals 0. So 5 squared is 25. And 5 times 25 is 125. So it's true, 0 does equal 0. The same thing would work if you were checking the negative. Negative 5 times negative 5 is positive 25, and it still works. So here is our answer. So we do this when there's no middle term. Alright, so for the next one, we're going to move the 128 over, so we minus 128 to both sides. And so we get 2x squared equals negative 128. Divide by 2. And we get x squared equals negative 64. Square root both sides. And we get x equals. So now, the 64, remember this can be broken down to negative 1 times 64. So the square root of 64 is going to be 8. And the square root of the negative 1 is I, and so we get plus or minus I. You could check that. So if we were going to check that, that would be 2 times 8i squared plus 128. And so what happens here is when we square the 8, we get 64. When we square the I, that gives us negative 1. And so 64 times negative 1 gives us negative 64. Times that 2 gives us that negative 128. So that negative 128 plus this 128 will equal 0. So it does work. Alright, and the last one, let's add 160 to both sides. And we get 4x squared equals 160. Divide by 4. And we get x squared equals 40. Alright, and so now we square root both sides. And so we get x equals plus or minus. So this, if you do the birthday cake method, so just as a review, we take the 40. And for the birthday cake, technically, if you're going to do it correctly, you start with the prime numbers. So these are the factors, and since it's the square root, we want the group of 2. So the 2 comes on the outside. This would stay on the inside. And it would be plus or minus. Alright, so the very first thing when you're graphing, you got to start with the vertex. So when it's in vertex form, we look inside the parentheses, and what makes this 0, remember that x is a liar, so this is going to be at 2, and then the number on the outside here, 1. So at 2, 1 is our vertex. And we draw our line of symmetry. So if you know the shortcut, great. If you don't know the shortcut, I'm going to show you how to do it without using the shortcut. And so if I were doing this the old-fashioned way, we have an XY table. My vertex is in the middle at 2, 1. So I would like to plot a point next to 2, and so I would plug 3 in. And so I take 3, I plug it in here. 3 minus 2 is 1. 1 squared is 1. Plus that 1 on the outside gives us 2. So at 3, 2, I have my next point. And then I would go another point over, 2, 3, 4, and go in order. And I want to plug 4 in. Okay, so 4 minus 2 now is 2. 2 squared is 4, plus the 1 on the outside gives me 5. So at 4, 5, I have my next point. And then I would use my line of symmetry and go over 1, over 1, over 2, over 2, and now I have my 5 points. So the only bad thing about doing the problems on the computer like this is when I draw the parabola, it's not the best looking parabola, but that's pretty ugly. Alright, so if you don't know the shortcut, you just plug in points, plug in x values next to your vertex. Alright, so the vertex over here on the next one, x is a liar, -5, -4. So at -5, -4 is my vertex. My line of symmetry goes through that. So if I'm at -5, I want to plug in a point next to the vertex, so I'm going to plug in -4. So if I put a -4 here, -4 plus 5 is 1. 1 squared is 1. But here, this negative on the outside makes it a -1. And so now -1 minus 4 gives us -5. And so we know that the graph opens down, so our next point should be going down. So if I make that into like a t-table, my vertex was at -5, -4, and I wanted an x value to the right of it. That's why I chose -4. So using that same thinking, my next point I'm going to pick is -3. So if I put a -3 here, -3 plus 5 is 2. 2 squared is 4. This negative makes a 4 negative, and -4 minus 4 is -8. So at -3, -8 is my next point. Now I just reflect it across the axis of symmetry, 2 away, 2 away. Try to do my best to draw a nice smooth graph. And there we go. Alright, now for this one. This is kind of unique when there's no middle term. This is in both standard form and vertex form at the same time. Because I could write this as x minus 0 squared minus 4. And so that means my vertex is at 0, -4. So my vertex, let's do this in red here, is at 0, -4. My line of symmetry so let's start with this idea of the t-table again. So I start in the middle at my vertex, 0, -4. I want to plug in a value next to the vertex. I'm going to plug 1 in. I would just go up here and I'd put a 1 where the x is, and so it would be 2 times 1 squared minus 4. You do your order of operations first. So 1 squared is 1 times 2. 2 times 1 is 2. 2 minus 4 is negative 2. So at 1, negative 2 is my next dot, my next point. So you can see the graph is going up. The a value is bigger than 1, so it's doing a vertical stretch. Whereas over here, it only went up 1. Now it went up 2. So it's going to stretch the graph out. So I plugged 1 in, so the next logical point to plug in would be 2. I'm going to get this out of the way. Now I'm going to plug 2 in. So 2 squared minus 4. Order of operations. 2 squared gives us 4. 2 times 4 is 8. And 8 minus 4 is 4. So when I expect my input's 2, my output's 4. So at 2, 4 is my next point. Now I'm going to go ahead and reflect it across the axis of symmetry. And do my best to draw a parabola. Alright, so now for this one, if it's in standard form, it's a little bit more work because I don't know where the vertex is. So a couple ways to do it. The easiest is just use our vertex formula, negative b over 2a. That'll tell us the input, or the x value of it. So my b is negative 4, so negative 4 over 2 times 1, which is just 2. So that's 4 over 2, which just becomes 2. So I know the vertex is going to be 2 comma something. So 2 comma something. So I know my line of symmetry goes here. Because the line of symmetry is our x value. So now to figure out where it's at, I just take the 2 and I plug it in. So we're going to have 2 squared minus 4 times 2 plus 3. So 4 minus 8. Remember we talked about this always being half of that. Negative 4 plus 3, negative 1. So at 2, negative 1 is my vertex. So if I was making a t-table, I would put that 2, negative 1 in the middle, and I'd pick a point to the right of 2, 3. And now I just plug the 3 in and do the work. So since x is 3, it'll be 3 squared. So that gives us 9 minus 12 plus 3. Negative 3 plus 3 is 0. And then plug 4 in. Uh-oh. Alright, so I don't know what happened there, but our vertex was at negative 2, negative 1. We plugged in 3. We were here. And so now if I plug in 4, it gives us 16 minus 16 plus 3. And so that gives us 3. So at 4, 3. And I really didn't have to plug that in if I would have thought about it first, because I know that that's the y-intercept. So I could have used this and then the line of symmetry to get that point, but I wasn't thinking. We'll do that on this problem down here. Alright, so there's my poorly drawn parabola. Alright, let's look at the next ones. Alright, so let's go ahead and do this one first. X is a liar, so my vertex is going to be at 4, 1. So at 4, 1. I know the graph is going up. So you could plug in a value next to 4. So if we start with 4, we know our output's 1. You could plug in 5. But when I plug in 5, I get 5 minus 4 is 1. 1 squared is 1. Half of 1 is a half. And then you're dealing with fractions. So here, instead of plugging in 5, just plug in a multiple. Just count by 2's. So I'm going to plug in 6. By plugging in 6, 6 minus 4 is 2. 2 squared is 4. It becomes 4. And so now I can take half of 4, which is just 2, and 2 plus 1 is 3. So it would be 6, 3. Got my line of symmetry. So again, using that logic, I wouldn't want to go to 7, but if I count by 2's and go to 8, that should be fine. So let me show a little bit more work here. So I'm going to take 8. 8 minus 4 is going to give me 4 squared. 4 squared is going to give me 16. Half of 16 is 8. And 8 plus 1 is 9. So if my input's 8, my output is 9. So at 8, 9 is my next point. 1, 2, 3, 4 away. 1, 2, 3, 4 away. And then reflect this one. 2 away. 2 away. And once again, my poorly drawn parabola. Okay, get this stuff out of the way. So let's see if we can be smart when we do this one over here. Alright, so we have negative x squared plus 6x minus 1. So I'm going to go ahead and put this on the graph now, that negative 1. I know that that's my y-intercept, and I don't want to forget about that. So let's find the vertex by doing x equals negative b over 2a. That's going to be negative 6 over 2 times. Now our a value here is negative 1. So I get negative 6 over negative 2, which equals a positive 3. If you did the work right, when you take that 3 and plug it in, to get your y value or your output, so this 3 squared becomes 9. This will always be half of this if you're plugging in the x value of the vertex. So now that's negative 9 plus 18, which is 9, minus 1 gives us 8. So I know my vertex is at 3, negative 8. Or positive 8, 3, 8. So at 3, 8. With my line of symmetry. So right now I'm going to go ahead and reflect this point. It's 1, 2, 3 away, 1, 2, 3 away. Alright, so now pick an x value close to your vertex. So I'm going to pick 4, and I'm just going to plug it in up here. So it's going to be negative 4 squared plus 6 times 4 minus 1. Again, do the exponent first. So the negative stays on the outside. So now it's negative 16 plus 24 minus 1. 8 minus 1, 7. So at 4, 4, 7 is my next dot. 1 away. Now I have my 5 points. Now I can draw my beautiful parabola. Alright, so we're going to solve this by factoring. So we have an x in common, so this becomes x times x plus 6 equals 0. Here we set them equal to 0. This one's already 0, minus 6 from both sides. And so now we have two answers, negative 6 and 0. So you could write it as x equals negative 6, comma 0. Alright, same thing here. We have an x in common. So you factor out an x, and you get 36x minus 25 equals 0. So when x is by itself on the outside, we know that x equals 0. Here, you might need to write that out. Add 25 to both sides. Divide by 36. You get x equals 25 over 36 and 0. Here, it doesn't have a GCF, so this is one where we're going to reverse FOIL. So you set up your parentheses. I know x times x gives me x squared, and so now we're looking to see what numbers multiply to negative 15 and add to negative 2. That's going to be negative 5 and positive 3. Remember, when x is inside the parentheses, it's a liar. So we have x equals, I'm going to do this one first, so I write the negative first, negative 3 and positive 5. Alright, here we want to have this thing equal to 0. So I'm going to add the 42 to both sides. We get x squared minus 13x plus 42 equals 0. And I want to factor it. And so I'm looking at this. Now you could actually start the Xbox method to help you think about it. Put the 42 here, the negative 13 here, and then what numbers multiply to 42 but add the negative 13? And that's negative 6 and negative 7. And so now, when we have it written like this, we use our zero product property, and we say x equals 6 and 7. And what's great about this is you can actually take the 6, plug it in, to make sure it works. Alright, we're going to solve this by factoring. So you may not be able to do this one in your head with the reverse FOIL. So this is where you would use the Xbox method. So a times c gives us negative 8. The negative 7 goes on the bottom. And so what two numbers multiply to negative 8 but add the negative 1? So that's negative 8 and 1. Then we take this into the box. The first number goes in the first box. The last number goes in the last box. And you take your answers. The negative 8x, 1x. And then by row, so what do these two things have in common? Well, they have a 2 in common. They have x squared and x, so they also have an x in common. Here, since it's a 1, the only GCF is 1. Same thing here, just a 1, but now they both have x, so I can just take an x. If you wanted to, you could write the 1x. They're both negative, so it's going to be negative 4. Because negative 4 times 1 is negative 4. Negative 4 times 2 is negative 8. So this becomes my factors. 2x plus 1 times x minus 4 equals 0. So here you should be able to look at that one and know that that's x equals 4. Here, if you need to, write 2x plus 1 equals 0 and solve it. Minus 1 divided by 2, x equals negative 1/2. So I have two answers, negative 1/2 and positive 4. You do the same thing here. But we've got to have this equal to 0, so I add 15 to both sides. So 6x squared plus 19x plus 15 equals 0. So I'm going to start with the x. And so it's going to be the a times c is going to go here. So 6 times 15 is 90. The middle term, the 19, goes on the bottom. And so what number is multiplied to 90? Make sure you realize that's a 90. But add the 19. So that's 10 and 9. Now you go to the box. First number in the first box, the last number in the last box, your answers in the remaining boxes, 10x, (9x). Now you factor out what they have in common. So 6 and 10, they share a 2, so you can take out a 2. X squared and x share an x. Here, 9 and 15 have a 3 in common. Same thing here with the 6 and 9, they have a 3 in common, so 3x. Here, 10 and 15 have a 5 in common. So when you go and you rewrite this, just take a second and go 3x times 2x is equal to 6x squared. 5 times 3 equals 15. So you're probably right. Split it up. Minus 5 divided by 3. Minus 3 divided by 2. There are my two answers. Okay, so we solved by completing the square when we can't factor this. So there's no factors that are going to multiply to 27 but add to 14. So when we complete the square, we need to get rid of this 27, move it to the other side. So I'm going to write x squared plus 14x plus a square equals negative 27 plus a square. So now to figure out what goes inside the square, what goes on the inside is half of b squared. So we look at that 14, take half of it, and square it. So half of 14 is 7. 7 squared is 49. So then we factor this. The whole reason we want this to be a perfect square is so that this becomes x plus 7 quantity squared. And so negative 27 and 49 gives us 22. Now we square root. And so we get x plus 7 equals plus or minus the square root of 22 minus the 7 over. So we get x equals negative 7 plus or minus the square root of 22. And then you just plug this in on your calculator. So when you put this in your calculator, you get negative 2.31 or negative 11.69. All right, let's try. I'm going to do this one since I have a little bit more room. So I'm just going to put the squares in there. So x squared plus 16x plus a square equals negative 49 plus a square. So now to figure out what goes inside the box, take that 16, divide by 2, and you get 8, square it. So this is going to be 64 and 64. So now we want to factor the left side, write it as a binomial. So x plus 8 squared is going to equal to 15. And so we square root both sides. Get x plus 8 equals plus or minus the square root of 15. Now minus 8 from both sides. And so we get x equals negative 8 plus or minus the square root of 15. And you're going to plug that into your calculator. All right, and so we get negative 4.13 or negative 11.87. All right, this one, let's just come over and do it in the middle here. So let's go ahead and add the 11 to both sides. So x squared minus 4x plus the box equals 11 plus the box. So take half of that. Half of 4 is 2. Square it. And so that's going to be adding 4 to both sides. So this factors to x minus 2 squared equals 15. Square root, square root. X minus 2 equals plus or minus the square root of 15. Add the 2 to both sides. You get x equals 2 plus or minus the square root of 15. Plug that into your calculator. All right, so that gives us a 5.87 or negative 1.87. All right, find the value of the discriminant. So the discriminant is based off b squared minus 4ac. So for every single one of these, I'm going to write b squared minus 4ac. And so that a value is the one in front. So I'm just going to take the a value and substitute it in. The b value is the one in the middle. And the c value is the last one. So I'm going to go ahead and plug that in, pause the video, and you can come back and look at it. All right, so I evaluated these, and I got 232, 0, and negative 152. And using the same process, I got negative 252, 0, and 80. But this question says, what are the types of solutions? So here, when we talk about types of solutions, we're talking about, does the graph cross the x-axis? And so if it doesn't touch the x-axis, it has a negative discriminant. so it has no real solutions. Okay, when it has no real solutions, that means it has two imaginary solutions. So if you remember in IXL, when I had a multiple choice question like this, it said no solutions. But that's not what I'm saying. I'm saying no real solutions. So I would just stick with this, two imaginary solutions. Now if it's 0, that actually means that when you graph it, it touches the x-axis only once. And so here this has one solution. And you could say one real solution. When it's a positive, that means it touches the x-axis twice. And so here we say it has two solutions or two real solutions. Alright, so let's take a look at these next two here. We're going to solve using the quadratic formula. So start by labeling your A, B, and C's. So A equals 7, B equals -2, and C equals -16. This is just because this is in standard form. So A is 7, B is -2, and C is -16. Then we're going to find the value of the discriminant. So B squared minus 4AC. So it's going to be -2 squared minus 4 times A times C. So you do that on your calculator, you're going to get 4 plus 28 times 16. 448 plus 4 gives us 452. And so now when we go to the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a, by already evaluating the b squared minus 4ac, it just saves me a little bit of steps. So it's going to be negative. My b is -2, so -2 plus or minus the square root of 452 all over 2 times a, which is 7. So this gives us 2 plus or minus the square root of 452 all over 14. Now just do this in your calculator. 2 plus the square root of 452 equals, divided by 14, and then 2 minus the square root of 452 equals, divided by 14. So you get -1.66 and -1.38. Okay, so we're going to do the same thing over here. So we have our ax squared plus bx plus c. So my a value is 2, my b value is 8, and my c value is -6. Start by finding our discriminant, b squared minus 4ac. It's going to be 8 squared minus 4 times a times c. So 64 plus 48, which equals 112. So now when we go to our quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So my b is 8, so it's -8 plus or minus the square root of 112 over 2 times a is 2, so 2 times 2 is 4. And now this is what I'm going to plug into the calculator. Alright, so you get 0.65 and -4.65. Alright, so to convert this into vertex form, what we're going to do is we're going to complete the square on this. And so to complete the square, we're going to get rid of the 10. So I'm just going to move the 10 to the other side. So I'm going to minus 10. And so on the left side, it's just y minus 10 equals x squared plus 6x. And so to complete the square, draw our little square. And we look at this. What's half of 6? Squared. And so I'm going to put a 9 here and a 9 here. So on the left side, the negative 10 plus 9 gives us y minus 1. Here on the right, we want to factor this. So this perfect trinomial factors to x plus half of that 6, which is 3. So this is equivalent to this. And now I just want to move the 1 to the right side to put it in vertex form, because in vertex form the y is going to be by itself. So I get y equals x plus 3 quantity squared plus 1. So this is equivalent to this. So just to make sure I got that right, I graphed this in Desmos, the x squared plus 6x plus 10. And now I'm going to graph the x plus 3 quantity squared plus 1. And if I'm right, it should be exactly on the other graph. So that means that these two things are equivalent. Okay, so now to go from vertex form to standard form. Remember, this square really just means that there's two of them. And so now you can just FOIL it out. X squared, so this will give us minus 5x minus 5x, so that gives us minus 10x. And then the negative 5 and negative 5 gives us positive 25. And then don't forget about that plus 2. And so this becomes y equals x squared minus 10x plus 27. So again, you could check that into Desmos. And then finally over here, we're going to go to vertex form. So to go to vertex form, I'm going to have to go to standard form first. So I'm going to FOIL that out. And so I get x squared plus 2x minus 8. And I'll go down here to give a little bit more room. So now I'm going to complete the square on this. So when I complete the square, I'm going to move that 8 over just to get it out of the way. So y plus 8 plus the square equals x squared plus 2x plus the square. So we take half of 2, square it, so we're going to add 1 to both sides. So now we factor the right side. So this factors to x plus 1 quantity squared. Here the 8 and 1 is going to give us 9, so y plus 9. So now to put it in vertex form, we subtract the 9 from both sides. And we finish with y equals x plus 1 quantity squared minus 9.